It's given here that the first term is 3, the nth term is 96, and the sum of the n terms of a geometric progression is 189. Now we need to find out the total number of terms present in this GP. So let's begin. Now we know that the sum of the nth term of a geometric progression is given by the first term, which is a1, multiplied to, so let r be represent the common ratio, r raised to the power of n minus 1. So let me know where r is the common ratio. Now it's given here that the first term has a value of 3 and the nth term has a value of 96. So 96 equals to 3 times r raised to the power of n minus 1. So dividing both sides by 3, so we have 32 equals to r raised to the power of n minus 1, or simply we can have r raised to the power of n minus 1 equals to 32. So we will be using this. So let's label this as equation number 1 for the time being. Now we also know that the sum up to the n terms of a geometric progression is given by the formula a, which is the first term will multiply to r raised to the power of n minus 1 divided by r minus 1. Now in our case, the sum is already given. So this means our sum up to nth term, which has a value 189. This would mean that 189 equals to the first term, which is 3. So 3 times r raised to the power of n minus 1 divided by r minus 1. Dividing both sides by 3, so we have 63 times r minus 1. And we're also cross multiplying with the denominator equals to 3. So we have already used the 3, r raised to the power of n minus 1. Now we will be rewriting this r raised to the power of n so that we can use equation number 1. We needed n minus 1 here. This can be also expressed as n minus 1. So since we are subtracting 1 from n, we are also going to add 1 to it. Minus 1. This is going to give us r raised to the power of n minus 1 multiplied to r minus 1. We can replace this value r raised to the power of n minus 1 with 32. So this will be equals to 32 times r minus 1. And on the left hand side, we already have 63r minus 63. We're distributing 63 to r minus 1. So let's rewrite everything. So we have 63r minus 32r. So that will be equals to 63 minus 1. So 63 minus 32, that will be equals to 31. So 31r is equals to 62. And we know that 2 times 31 is 62. So our r ratio, the common ratio, is 2. So we have obtained our common ratio. So we have now our first term. So our first term a1, that has a value of 3 and the common ratio r is equals to 2. So using this, we can also obtain the total number of terms, and let's use the nth term as well. The nth term was given having a value of 96. So we know that an is given by a times r raised to the power of n minus 1. So we can substitute all these values here. So 96 will be equals to 3 times 2 raised to the power of n minus 1. So 96 divided by 3, so that's 32. So 32 equals to 2 raised to the power of n minus 1. Now 32 can be also expressed as 2 raised to the power of 5, which will be equals to 2 raised to the power of n minus 2. Since the base is exactly the same, bases are equal, so the exponents are also going to be equal. To equating the exponents, we have n minus 1 equals to 5. Solving for n, we get n equals to 6. So that means in the given GP, there are 6 number of terms.